Hello, this is Abhijit and you are watching my YouTube channel AB Study Circle. Do like, share, comment and subscribe. In this video, we will discuss about a new term that is known as energy interaction. In energy interaction, we have two types of energies, that is work and heat interactions. Now, in normal way, we define work as work is done by a force as it acts upon a body moving in a direction of the applied force. Work is done by a force as it acts upon a body moving in the direction of the applied force, which means W will be equal to F into D, where D is the distance the body is moved and force is the force applied on the body. Now, there is little alteration to the definition in terms of thermodynamics. In terms of thermodynamics, work transfer or interaction is defined in this way. Work is said to be done by the system if the entire effect on things external to the system can be equated to the raising of weights. This doesn't signify that weights may be raised. In actual, weights may not be raised, right? May or may not be raised. This raising of weights symbolizes that there is some kind of change in the surrounding due to the system, right? For example, let's show it in a pictorial way. Suppose we have a battery. It is a battery. It is a motor. There are two terminals which are connected to the battery, and there is a fan. Right. Now, if I describe this motor and battery enclosed within this dotted line as the system, if this I termed as system, then the entire effect on things external to the system can be equated to the raising of weights. Weights may not be raised, right? Due to this system, the fan will move, means there is some kind of change in the surrounding. This is system and this is in surrounding, right? So we got to know that there is some kind of change in the surrounding due to this moving of this fan because of this system. So we say that work is done by the system, right? Again, another example where we will raise the weights actually. Suppose in place of this fan we have a pulley and weight system. This is battery, again this is battery, this is the terminals, right? This is the weight, right? And if we see the whole battery and motor as a system, then when the battery is used to operate this motor, then this motor will run this spindle, and when this spindle is run either clockwise or anti-clockwise, then this weights will rise or lower, means there is some change in the system. This is the system and it's in surrounding. So as we think that we got an idea what work transfer means, right? Now we further move to describe the conventions, sign conventions of work transfer, right? Sign convention for work transfer. If work is done by the system, if work is done by system, it's positive, and when work is done on the system, it is negative. That means when the system is doing some changes in the surrounding, it's positive, and when the surrounding is doing some changes in the system, it's negative, right? The pictorial representation, it's the system, this is work done by the system, it's positive. Work done on the system is negative, right? As we know that work is primary or basic formula for work is force into displacement. So here also the unit of work transfer is Newton meter or joule, right? Now basically as work transfer is concerned with system and surrounding, in previous video lectures we have discussed about types of system, right? We have closed system, we have open system, and we have isolated system. In isolated system, which means there is complete isolation, means there is no transfer of energy from the system to surrounding or from surrounding to system. So we will not consider that. But if we see open or closed system, then we can have in closed system, that is non-flow work, and open system, that is flow work. Means in open system we are work is considered as open system work, right, for closed system. So types of work. Closed system work or non-flow work. Second is open system work, flow work. We will see these two type of system in detail, right? But we will start with closed system first. After completing the detailed analysis of closed system, we will move further to open system work. But first we should know about power. Basically power is same what we have used in other mechanical areas. Power is the rate of work done. Rate of work done, right? Unit will be joule per second or watt, right? Now moving further, as I said that we will first deal with closed system work, and after that we will move to open system work. So starting with closed system work. Closed system work. Let's see this closed system example. In previous video lectures I have showed that a piston cylinder arrangement without valve is a closed system, right? Now this is a closed system and this is a piston. Now when gas or any other substance is filled inside, it will have a pressure on this piston, right? Pressure P. When the pressure P will act on this piston, the piston will move through a distance. Suppose it moves through a dx distance, dx, right? So according to our basic formula for work done, that is W is equal to F into X, we have d cut W or del W. I will tell you why we have put d cut or del before in this, right, in later on, is equal to F into dx. Again, F is what? It is pressure into area, right? Pressure into area. Now d cut W will be equal to P into A into dx. Again, d cut W will be equal to what this means? Area into distance. Into distance. This means volume. P into dV. Right? Then if we take integral, W will be equal to integral P dV. Yes, we got the formula for work done for a closed system. It is work done for a closed system. Now let's put this on a PV plot or PV space. PV space. Let a process is from state 1 to state 2. Great. Like this. Let for the constant pressure P, we have a area under the curve for this distance, that is dV. So the area under this curve dA will be equal to P into dV. Then area will be integral P dV. If we see, this is equal to closed system work. So we can say that closed system work is equal to the area under the curve projected on volume axis of a PV plot. Right? Good. Now, see, as we have said that when the area under the curve projected on volume axis gives the closed system work. So suppose there is a work from 1 to 2, right? This one. So if you see, this is the area under the curve in volume axis, right? Volume axis, right? This is the area 1 to 2. Again, okay, for this it is, I will say that it's 1A, B, 2. For process A, the area will be in the shaded region will be 1A, B, 2, right? Now if this process moves would be like this, 1 to 2, the initial and final states are same, but the processes are different. It is process B, right? For process B, it will be under this curve, right? For B, it will be 1A, B, 2 for B, and for A will be this. As we see that for the process B, it covers a larger area in respect to the process A. Means if the process changes and the initial and final states are same, but the process changes, then the work done will also change. That means work is a path function. Work is a path function. That means work is not a property, right? Because properties are state function, but work is not a property because it's a path function, because for different processes within the same initial and final stages, the work is different. So as it is not a property, it will not be exact differential. Work is in exact differential, right? Therefore it is written as del W or d cut W, which you see in your textbooks like PK Nag. Now some points to remember. Note. First, work will be obtained only when it crosses boundary. Second, process should be reversible. It should be noted here for closed system work. Right? That's all for this video lecture. In the next lecture, we will discuss about ideal gas equations. Till then, goodbye, and if you like this video, do share, comment and like the video, and don't forget to subscribe my channel.